Usually when we talk about building a city, there's a very predictable order of operations.
Right.
You map out the grid, you lay down the plumbing, pour a massive concrete foundation, and, you know, only then do you start building the skyscrapers.
Yeah, you never just throw up glass towers on top of a swamp and hope you can retrofit the plumbing later.
Exactly.
Because the moment the ground shifts or that makeshift plumbing inevitably fails under pressure.
The whole glass tower comes down.
Yeah, it's a structural nightmare. Complex systems, I mean, they just need solid bedrock.
Yet, when you step into the world of cryptocurrencies, it feels like the last decade was defined by people rushing to build glass towers on swamps.
It really does.
We've watched these networks just explode in popularity, throwing up massive digital economies while entirely ignoring the structural nightmares underneath them until it was just, way too late.
It's the quintessential move fast and break things ethos,
Right.
but applied to the foundation of what is supposed to be our global financial infrastructure. Which is wild.
And that brings us to our deep dive today. We are looking at a really comprehensive analysis titled Cardano ha resuelto el mayor problema de las criptomonedas, which translates to Cardano has solved the biggest problem of cryptocurrencies.
That is quite the claim.
It is an incredibly bold claim, and our mission today is to really put that under a microscope. Sitting here in the year 2026, the blockchain landscape has matured significantly.
Oh, absolutely.
We want to know if Cardano's notoriously rigorous, peer-reviewed approach truly fixed crypto's historical flaws, or if it just created an entirely new set of headaches for everyone. Okay, let's unpack this. What actually is the biggest problem in crypto?
Well, to evaluate that claim, we really have to split the problem into two distinct but deeply connected parts.
Okay.
First, you have the massive, fundamentally unsustainable energy consumption of the early network.
The elephant in the room.
Exactly. And second, you have the blockchain trilemma, which is this notoriously difficult balancing act of trying to make a network decentralized, secure, and scalable all at the same time. Historically, if you maximize speed, well, you sacrifice security or you gave up decentralization.
Right. And for those of you listening, the reason you should care about this balancing act isn't just for the sake of some, academic thought experiment.
No, not at all.
If a network cannot scale sustainably and securely, it will literally never become the underlying infrastructure for the real-world financial systems or the supply chains or the digital identity systems you interact with every single day.
Yeah, if the foundation is flawed, your data and your money are sitting on that swamp we talked about.
Exactly. So we have to start with the most glaring world-impacting problem that plagued the early space, which is the energy drain.
The energy drain was, it was catastrophic.
The numbers in this source are just staggering. We're looking at proof-of-work systems, specifically Bitcoin, consuming roughly 150 terawatt hours annually. To put that into perspective for you, that is comparable to the energy consumption of entire industrialized nations.
It's unbelievable.
It's a digital system powered by a physical furnace.
Right, because in proof of work, the network is secured by miners competing to solve highly complex, arbitrary computational puzzles.
Right.
And the more physical electricity you burn, the higher your chances of winning the right to process the next block and earn a reward.
So the waste is the point.
Exactly. That massive energy drain is actually a deliberate design choice. It acts as a physical barrier to entry to prevent malicious actors from just flooding and taking over the network.
So enter Charles Hoskinson and the team at IOHK, which is Input-Output back in 2017. They launched Cardano with a fundamentally different philosophy, right?
Completely different.
Instead of trying to build a slightly more efficient furnace, they wanted to redesign the thermodynamics of the system entirely. And they introduced Ouroboros.
Right, their custom proof-of-stake mechanism. The mechanics of Ouroboros, they just shift the paradigm entirely. Instead of burning electricity to solve puzzles, the protocol selects block leaders probabilistically based on their stake.
Meaning the amount of ADA they hold or have delegated.
Right, so your influence on the network is determined by your vested economic interest in its health, not by how many physical servers you can, plug into a power grid.
And the result of that architectural shift is wild. The source notes that Ouroboros uses roughly 0.05% of the energy of a proof-of-work system.
Which is a massive reduction.
It really is. But, if Bitcoin is an athlete trying to run a marathon while carrying a diesel generator, Cardano is using a smart electric bike.
I like that analogy.
But shutting off the diesel generators is the easy part, right? The real challenge is keeping the network secure without that massive physical wall of electricity keeping the bad actors out.
Right.
I mean, if there's no physical cost to attacking the network, what stops a cartel of wealthy users from just overwhelming the system?
Well, what's fascinating here is how they replaced brute physical force with verifiable mathematics.
Uh,
Before Cardano, proof of stake was largely an experimental concept. Developers liked the idea of saving energy, but no one had definitively proven that it could match the security guarantees of burning all that electricity.
it's just a theory.
Right. But that narrative completely changed with a seminal 2017 peer-reviewed paper led by Aggelos Kiais.
Ah, right, titled A Provably Secure Proof-of-Stake Blockchain Protocol.
Yes, and provably secure is the phrase that really anchors their entire philosophy.
They didn't just write a white paper with some neat ideas.
No, they mathematically modeled how the network behaves under various severe attack scenarios. They proved that as long as 51% of the stake is held by honest participants, the protocol mathematically holds up.
So how does that actually work in practice?
Well, they engineered a system of cryptographic sortition. Think of it as a verifiable, highly secure, unpredictable lottery ticket hidden deep inside the blockchain itself. Nobody knows who the next block leader is going to be until the exact moment they are selected by the protocol.
So you can't game the system.
Exactly. Because the selection is computationally unpredictable, malicious actors cannot collude in advance to attack specific block producers. The protocol basically replaces the physical barrier of electricity with a mathematical barrier of game theory and advanced cryptography.
So they successfully engineered the furnace out of the equation.
They did.
But taking away those physical machines inherently changes the entire dynamic of who controls the network and how data is structured.
Absolutely.
If they solve the energy crisis, we have to look at the next causal step.
Oh?
Did that solution inadvertently destroy the network's decentralization or its security?
And that takes us right into the trilemma. The source is very clear on their methodology here. When facing the trilemma, Cardano explicitly prioritized decentralization and security at the base layer above all else.
Okay.
They basically drew a line in the sand and refused to compromise the foundation just to get faster transaction speeds.
And the decentralization metrics actually hold up. I mean, instead of a handful of massive mining farms controlling the hash rate, Cardano operates through thousands of independent stake pools.
Right.
The source points to their strong Nakamoto coefficient showing a highly distributed network that really avoids the severe validator centralization we've seen on some other proof-of-stake chains.
Yeah, the decentralization is solid, but the security side is where the engineering gets incredibly granular.
How so?
Well, in early, flawed proof-of-stake systems, there was a fatal vulnerability called the nothing-at-stake problem.
Right.
If a blockchain experienced a fork, validators in early systems could simply vote on both sides of the fork simultaneously because voting costs zero energy.
Oh, I see.
Yeah, they were guaranteed a reward regardless of which chain won, which completely destroys the network's ability to reach a single, verifiable consensus.
Because they had no skin in the game.
Ex-
But Ouroboros solves this through those evolving mathematical models we just talked about, heavily penalizing bad actors and mathematically resolving forks without relying on energy constraints.
Right, so the base layer consensus is secure.
But I want to look at the application layer, because this is where the source highlights their use of formal methods and the Plutus smart contract language.
Yes, Cardano's smart contracts are written in Plutus, which is deeply rooted in Haskell.
And Haskell's a pretty intense language, right?
It is. It's a functional programming language heavily utilized in industries like aerospace, defense, and high finance.
Wow.
Yeah, these are environments where a single floating point error or a minor bug doesn't just mean a glitch.
It means catastrophic failure.
Exactly. Haskell allows developers to use formal methods to mathematically prove that their code will behave exactly as intended under every possible condition before it is ever deployed to the live network.
And they pair that rigorous language with a unique accounting model called EUTXO.
The extended unspent transaction output model.
Right. Which is a massive departure from the account-based model used by Ethereum and most of the broader EVM ecosystem.
It is. And to understand the mechanism here, think about how an account-based model works. It functions like a single, massive, shared global state.
Okay.
A transaction's outcome can radically change depending on what else is happening on the network at that exact millisecond.
It's like a single shared Google Doc where thousands of people are trying to type in the exact same paragraph at the same time.
That's a perfect way to describe it.
You might try to execute a trade, but because someone else typed over your line a fraction of a second earlier, Your transaction fails, but you still lose your gas fees.
Right. It creates unpredictable chaos and a massive surface area for exploits.
And the EUTXO model completely bypasses that chaos.
Yes, it is fundamentally deterministic. Instead of a shared Google Doc, think of EUTXO as a stack of self-contained digital briefcases.
Okay, briefcases.
Every transaction carries its own local state, its own specific conditions, and its own exact execution cost. You can verify the contents and the logic of your specific briefcase offline, locally, before you ever broadcast it to the network.
So you know beforehand.
You know with 100% certainty whether the transaction is valid and exactly how much it will cost.
Okay, I understand the elegance of the EUTXO model and the mathematical certainty of Haskell.
Yeah.
But stepping out of the theoretical architecture for a moment, I look at the reality of the market. The source notes that IOG published 24 peer-reviewed papers in 2025 alone.
They've been busy.
Right, but it sounds like Cardano is the straight-A student sitting in the front of the classroom doing extra peer-reviewed homework. Meanwhile, the rest of the industry is out in the wild actually building things.
I hear you.
Does spending all this time writing academic papers and coding in obscure languages actually translate to a usable product for you and me? Or are they just over-engineering a ghost town?
Well, the tension between academic rigor and market speed is the central conflict of their ecosystem. There's no denying that.
Right.
But you have to look at the specific real-world use cases Cardano is targeting. If you are launching a quick meme coin, you do not need formal methods. You want rapid deployment.
True.
But Cardano has historically pursued massive enterprise and governmental applications.
Like the digital identity systems for millions of students in Ethiopia.
Exactly.
Or tracking multi-billion-dollar agricultural supply chains from farm to port.
Exactly, those types of deployments. When you are putting the educational credentials of 5 million students on a blockchain, or tracing the exact origin of international grain shipments to comply with global trade regulations, you cannot afford a smart contract bug that corrupts the database.
No, definitely not.
You cannot have a multi-billion-dollar supply chain halt because someone deployed a meme coin that spiked network gas fees and caused your transactions to fail.
That makes a lot of sense.
Those institutions require the deterministic, locally verifiable nature of EUTXO. They want a mathematically proven bedrock.
Okay, so they've engineered these perfect, secure briefcases that institutions can trust.
Right.
But if those briefcases are packed with heavy cryptographic proofs, how do they move them quickly? Because the source's data on the scalability bottleneck is a brutal reality check.
It is.
Extreme base layer security historically creates severe latency, and the numbers here in 2026 are sobering.
The trilemma always demands a toll.
Yeah. The theoretical base layer speeds are listed around 250 TPS, but the observed real-world peaks are hovering at a very modest 10 to 18 TPS.
Yeah, it's low.
So building Cardano is like engineering a structurally perfect, indestructible 10-lane highway, but right now the toll booth is only letting 18 cars through every second.
That's exactly what it's like.
It does not matter how secure your infrastructure is. If you are only processing a dozen transactions a second, globally, you cannot run the world's financial operating system.
That bottleneck is the direct result of prioritizing decentralization and security on the base layer. Every node needs sufficient time to verify those complex deterministic proofs across the global network.
So how do they fix it?
Well, Cardano's long-term blueprint for scaling was never to bloat the base layer. It was to build robust off-chain solutions, primarily through the Hydra protocol.
Let's dissect the mechanism behind Hydra, because the source positions it as their ultimate scaling weapon. It utilizes isomorphic state channels.
Yes. And the term isomorphic is the critical key here.
What does that mean?
It means the layer 2 channels use the exact same rules, the same Plutus scripts, and the same EUTXO accounting model as the main base layer.
Oh, wow.
Yeah, developers don't have to rewrite their entire application in a different language just to scale it. Imagine you and I sit down to run high-frequency microtransactions, maybe an enterprise settlement system between two banks.
Okay.
Instead of broadcasting every single microtrade to the entire global network, which is slow and expensive, we open a dedicated Hydra channel.
So we transact instantly between ourselves within that channel.
Exactly. We can execute tens of thousands of complex, smart contract-driven transactions instantly.
Because it's just between us.
Right. And when our business is concluded, we close the channel and only record the final mathematically verified net balances back to the main Cardano blockchain.
Wow. So you drastically reduce the traffic congestion on the main network while retaining the base layer's security guarantees.
Precisely.
Hydra theoretically promises to multiply throughput into the hundreds of thousands or even millions if you run enough parallel channels.
It does.
And the source mentions the 2026 Protocol 11 update, aiming for around 1,000 TPS via Layer 2 routing.
Right, alongside consensus upgrades like Ouroboros Laos, which actually separates transaction endorsement from block production to increase base layer throughput.
So the architectural blueprint for massive global scale is fully drafted and actively being deployed.
It is.
But blueprints and peer-reviewed papers still have to survive contact with reality.
They do.
And I want to highlight a specific incident from the source that serves as a massive test of their academic theory.
Oh, I know what you're going to bring up.
In November 2025, there was a major fork incident. A highly complex, basically poisoned transaction interacted unexpectedly with the ledger state, causing a bug that disrupted block production across the network.
Right.
The straight-A student got hit with a pop quiz and struggled. Doesn't this prove that even the most rigorous, peer-reviewed science isn't immune to real-world chaos? Even with Haskell and EUTXO, human-written code is never immune to bugs.
Well, this raises an important question about how we actually evaluate network resilience. You are entirely correct. No complex system is immune to edge cases or bugs, regardless of how many formal proofs you run prior to deployment.
Right.
But the true test of a decentralized architecture isn't whether it achieves the impossible goal of zero bugs, it's the mechanism of how the system degrades when a black swan event occurs.
Oh, I see. It's about graceful degradation rather than catastrophic failure.
Exactly. When that poison transaction hit in November 2025, the network didn't suffer a catastrophic chain split.
The EUTXO model isolated the damage.
Yes. User funds weren't drained by an exploit. Block production slowed significantly, but the system degraded gracefully. Node operators quickly identified the anomaly, and a patch was deployed rapidly through the decentralized community.
Right. They didn't have a centralized foundation step in and just hit a master pause button on the blockchain.
Which we've routinely seen happen on faster, heavily centralized networks when they encounter a bug.
Oh yeah, all the time.
The predictable recovery and the decentralized coordination in resolving the bug proved the resilience of the architecture. From an engineering standpoint, a system that can take a critical hit, bend without snapping, and recover autonomously is far more valuable than a system that moves at lightning speed but shatters the moment an anomaly occurs.
Okay, the tech is resilient. The academic foundation is unshakable. But we have to transition from the realm of technology into the reality of market adoption. Let's do it. Because survival in 2026 is a blood sport. The source does not pull any punches regarding Cardano's market share. They have a significantly lower total value locked, or TVL, and a smaller active user base compared to dominant competitors like Ethereum and hyperfast alternatives like Solana.
The current market dynamic remains incredibly asymmetric.
Yeah.
The broader crypto space heavily rewards speed, aggressive venture capital marketing, and immediate retail yield. Capital aggressively flows toward hype and rapid iteration.
Here's where it gets really interesting, though. The source notes that Cardano's counter-strategy focuses heavily on the Voltaire era, their massive push into fully decentralized on-chain governance.
Right.
They are handing the keys of the treasury and the protocol parameters over to the community.
Which is huge.
It is, but the source says Cardano's motto is basically slow and steady wins the race. But if your ecosystem is moving at a methodical, academic pace, and developers are all flocking to chains with the hype, the venture capital, and millions of active retail users, do you end up winning a technological race that everyone else has already left?
If we connect this to the bigger picture, we have to differentiate between retail hype cycles and institutional adoption curves.
Okay, unpack that.
Retail hype moves at the speed of social media. It changes allegiance every single week based on yield farming and token airdrops.
That's true. It's very fickle.
Exactly. But the kind of adoption that integrates a blockchain into a sovereign nation's telecom infrastructure or modernizes a massive multinational banking system that moves at a glacial pace.
Right. Their risk tolerance is virtually zero. They can't afford to chase the hottest new layer one.
Exactly. A central bank looking to tokenize real-world assets in 2026 isn't evaluating which chain has the highest daily meme coin volume.
Obviously not.
They're evaluating legal predictability, mathematical security, and disaster recovery. They are looking for a system that won't suddenly fork, suffer a critical outage, or drastically change its core monetary policy just because a new NFT project clogged the network.
They want the boring, predictable briefcases.
Yes. Cardano's core strategy isn't to compete in the daily retail hype cycle. Their strategy is to be the mathematically proven bedrock ready and waiting when the larger, slower, multi-trillion-dollar traditional entities are finally ready to migrate on-chain.
Uh,
They are betting that the deterministic nature of EUTXO and the rigorous governance of Voltaire will ultimately win over major global entities long after the noise of retail speculation fades.
so what does this all mean for the broader landscape of the industry? We can clearly see the full trajectory Cardano has taken.
We can.
They looked at the massive 150 terawatt-hour furnace of early crypto and elegantly engineered it out of existence via the Ouroboros mechanism.
Yeah.
They laid down a scientifically undeniable foundation for security using formal methods and deterministic programming, securing the base layer against the Trilemma's most difficult hurdles.
They proved that you can achieve global consensus without a physical energy barrier.
However, conquering that final pillar of the Trilemma scalability remains their most critical ongoing test in 2026.
It does.
Architectural upgrades like Hydra and Ouroboros Laos provide the theoretical blueprint for massive throughput. But they are fighting an uphill battle in a market war against flashier, highly capitalized competitors.
Yeah.
It's a profound lesson for you, the listener. Whenever you hear promises from the tech world, especially in a space as chaotic as crypto, you have to look past the surface-level metrics. You have to ask yourself, are they building their glass towers on a swamp of hype, or are they painstakingly pouring the concrete of rigorous science, even if it takes a decade to dry?
And that inherent tension between high-level science and widespread accessibility brings up a crucial dynamic we rarely examine. Well, consider this. Cardano relies on elite, peer-reviewed cryptography, formal methods, and highly complex programming languages like Haskell to ensure its provable security.
Right.
But if the underlying technology becomes so mathematically advanced that only a handful of academics globally can truly audit and understand the code from scratch, does extreme scientific rigor accidentally create a new kind of centralization?
Oh, wow.
A centralization of intellectual understanding, something to think about the next time you trust a trustless system.
Wow. That is definitely something I'm all over. Well, thanks for joining us on this one, and we'll catch you in the next deep dive.